Welcome to EyeOpener, powered by Siemens. And now, your host, Kurgan Sanger.
Natalie, one of the questions that we frequently get asked from a customer perspective is when it comes to starting a project, when it comes to the asset templating process, how are their assets put into the app? And, you know, what historical data is required for that process to take place?
Yeah, so whenever data is put into the app, the algorithms automatically start learning. And they just take a minimum of 2 days to learn. So in that regard, we don't require historical data. And that's something that is kind of shocking to a lot of our customers, because that we often get the question, how much data do we need? This is verbatim. How much data do we need to train the model? And I always kind of groan internally because there is no model in the traditional sense that they're thinking of. It is AI and machine learning. I am not going in and designing a specific, parameters for every individual asset or every individual data point. The point is to scale. So we let the AI and machine learning do that. But we can't put guardrails kind of on the algorithms. Some obvious ones are, and we'll discuss these during the asset templating process. I'll ask a customer, say, hey, are you interested if the vibration goes down on this asset, or are you only interested if it's going up? They never say they're interested in it going down. So what we do is we can go into the algorithms, and in bulk, we can basically disable downward detections. So right off the bat, even sometimes like when data has just started coming in, we can kind of decrease an incidence of false positives. Before we've even seen data, we can arrive at those conclusions. But when it comes to training the model, there is no such thing. The model learns automatically. It's not a model in the traditional sense of like data science. So yeah, no historical data needed. Just get it into the app.
Just get it in. Okay. That makes sense. Well, like you said, I think this question is asked a lot, how much data is required for it to work? Yeah. So like you said, it's just, you can't actually put a number on it, because I guess it depends on each different type of, asset and what they're looking to achieve. So I think from a customer perspective, they always have these, maybe assumptions because they just want it to avoid failures that they have. And I guess when it does come to monitoring your assets, it's a very kind of up and down process, isn't it? So it takes time. I guess putting that data into Senseye predictive maintenance, it takes time to monitor and to understand the algorithms and to see what's going on.
It is. So what's interesting about what you said there is it's not just about the algorithms learning and the app learning and just providing you amazing outputs. It is equally the users learning and engaging. They are not going to get any success with the app if they don't use the thing. Mm-hmm. They have to get in, they have to provide feedback, they have to start thinking critically, because I don't know their machines. Yeah. I know data, but I don't know how their machines work. So they have to get out there and start thinking, how else can we monitor this? And the people that do that have huge success. But it's the ones that think, okay, well, data's in, that's it. We can just, click a few buttons every now and then, and why aren't we getting great results? Well, you have to use it. You have to work with it.
So from your experience of looking into the data and understanding the data, it would be really interesting to understand what is one of the main issues you've encountered when dealing with that side and actually focusing on the data within the app.
So it's kind of twofold. One of the biggest difficulties is, like I said, when we talk about the asset and the data with the customer beforehand, we're not usually looking at the data when we have that discussion. So when we get it into the app, oftentimes the data is influenced by outside factors that the customer had no idea was actually going on. So we either need to provide more context in order to take away the influence of whatever that factor is and get us a nice steady state signal that the algorithms can look at, or we can use the asset in kind of a group. So every time I say the word asset, I'm really talking about asset type. So we'd much rather see a big group of like assets in the app. So if you want to onboard 1,000 assets, I'd much rather see 1,000 of the same type than 1,000 assets and 40 different types, because the bigger the group you have, the more context you have. So we've seen before customers might, you might ask, what happens if you onboard an asset and it's already in a state of failure? How do we recognize that? Well, the algorithms won't know it's in a state of failure because all they know is what you've told it. So they've learned from, the first 2 days of data, and they continuously learn after that. They don't stop, but that's their starting window. If it's already in a failure state, then they think that's normal for that asset. But if we have a whole fleet of assets that are really meant to be doing the same thing at the same time, one of the first things we like to do when we get data in is look at the assets in the fleet to see if any of them are sitting like maybe at a much different baseline, or if they're much more erratic with their data. And that way we can identify if one's in a state of failure. And in the same way, if they're all process dependent on something else, we can look at them in a group and see if they're all varying in the same way at the same time. And if one isn't, then we know maybe that one's in trouble.
Okay. And how would you define a state of failure?
A state of failure I'd really define more as a degradation. So what Sensei is doing is we're not predicting failures, we're predicting when they need to maintain it, which ideally is before it fails, right? So we might see the data starts to, if it's steady, it might start to increase at a rate. It might not even be increasing at the same slope or the same rate of change. It might start slow and then start creeping up. Sometimes the data gets much noisier, so you'll see big spikes jumping around when usually it was much smaller sort of range and spike. So it really depends on the signal we're looking at, but really it's just change from typical behavior. If we have a good steady state condition indicator, it's going to be ideally flat or following some control parameter or contextual measure. And if it deviates from that, it ought to be in a state of failure.
So Natalie, to summarize this topic around data cleansing and preparation for PdM, what would you say are the 3 key learning takeaways that someone could take from this topic that we've just discussed?
So I would say the first one is that you need to provide predictive maintenance solution like Sensei with steady state condition indicators. And if it's not already like that, we can help make the data in that format. The second takeaway is that if there isn't something in the data to indicate a failure, the algorithms aren't going to find it. So we can work with little data, but the expectation has to be that we might not find everything unless you provide the right condition indicators. And then the last takeaway is that there's a huge benefit to onboarding many of the same asset type. So a whole fleet of assets, because you can gain a lot more insights than if you're just looking at one by itself.
Okay, that's really great to know. I think especially touching on the final takeaway that you mentioned about essentially being able to do it in bulk, that makes it a lot easier. And especially within the Sensei predictive maintenance app, you're able to do that.
Yeah, so I would say if I want to onboard 1 motor or 1,000 motors, for me, it's the same amount of effort. So for the user, it's the same amount of effort, and you'll get so much more value if you have many more than just one.
Yeah, no, that's great. So Natalie, on our previous episode, James Loach asked a question for our next guest on the show. That question is around when you were growing up, did you imagine yourself to be working in maintenance, and what led you to that?
Okay, so in short, no. I was actually all set to go to school for music, and at the last moment I decided to go for engineering, and my PhD work was in biomedical engineering, so I was basically doing predictive maintenance on humans. Oh, wow. When I decided to leave academia, I wanted to try my hand in industry, and I found this role, and I thought, that's exactly what I'm doing, and machines might be easier than people. So that's how I'm here.
Oh, amazing. Well, yeah, thank you for answering that question. And I guess, for our next guest on the show, if you could ask them a question, what would it be?
I would say maybe what has been the most unexpected aspect of working with Sensei predictive maintenance.
Thank you so much, Natalie, for joining me on this episode today, discussing the topic around data cleansing and preparation for PdM. It's been really great to have you on this episode.
Thank you. It was a pleasure.
Thank you. A big thank you to our audience for tuning in on today's episode. Please like and subscribe to our channel and stay tuned for the next one in the series. Thank you.
To find out more, search Senseye Predictive Maintenance.